All right, so section 1.7, we are looking at perimeter, circumference, and area. And so just a refresher on those formulas for us. For a square, each side length is exactly the same, so we represent the side with lowercase s. And so the perimeter would be 4 times the length of the side. Area would be the length of the side squared. For a rectangle, we have a length and a width. So long side's the length, short side's the width. Perimeter for a rectangle is 2 times the length plus 2 times the width. Or the area, to find it, we just multiply the length times the width. Next up, a triangle. Basic formula for a triangle, you've got sides A, B, and C. So to get the perimeter, all we do is we add the 3 side lengths together. For the area, we multiply the base times the height, and then divide it by 2 or multiply that by 1/2. And for a circle, we don't have a perimeter, we have a circumference. So circumference is 2 times pi times the radius. And the radius is the distance from the center to the side, or to the edge of the circle. And then for area, it's pi times the radius squared. And if you don't know, pi is a ratio of the circle's circumference to its diameter. So if we take the circumference, the distance around the circle, divide it by its diameter, we should get the value pi. Alright, so first example, find the perimeter and area of a rectangle of length 4.5 meters and width 0.5 meters. 4.5 meters for the length, 0.5 meters for the width. And so for perimeter, since it's a rectangle, 2 times the length plus 2 times the width. So it'll be 2 times 4.5 plus 2 times 0.5. 2 times 4.5 is 9. 2 times 0.5 is 1. So the perimeter is going to be 10, and the units are meters, so 10 meters. Then for the area of a rectangle is length times width. So for our area here, it's simply 4.5 times 0.5. To give us an area of 2.25, and it's meters squared. Alright, next example says a road sign consists of a pole with a circular sign on top. The top of the circle is 10 feet high. And the bottom of the circle is 8 feet high. So top of the circle is 10 feet, bottom of the circle is 8 feet. We want to find the diameter, radius, circumference, and area of the circle, and then use 3.14 as an approximation for pi, or in other words, when we multiply by pi or use pi in a formula, we're going to use 3.14 for that value. So for the diameter, which is the distance all the way across the circle, that's going to be the difference between these two heights, right? 10 feet to 8 feet. That's the width of the circle, or the diameter. So 10 minus 8 can give us 2 feet for the diameter. And then a radius is simply 1/2 the diameter. So our radius here is going to be 1/2 times 2 feet, which is going to give us 1 foot from the radius. And then from there we can figure the circumference and the area. So circumference the formula 2 pi times the radius. So our circumference is 2 times, we're using 3.14 for pi, times the radius of 1 foot. So our circumference is 2 times 3.14, which is 6.28, times 1 is just 6.28. Put the units on it, 6.28 feet for the circumference. And then for the area, formula is pi times the radius squared. So our area pi, we're going to replace it with 3.14 times 1 foot squared. This one goes 3.14 times 1 foot squared, right? 1 times 1 is 1. Feet times feet is feet squared. Ultimately, our answer is 3.14 feet squared for the area of that circle. So a maintenance worker needs to fertilize a 9-hole golf course. The entire golf course covers a rectangular area that is approximately 1,800 feet by 2,700 feet. 1,800 feet by 2,700 feet. Each bag of fertilizer covers 20,000 square feet. How many bags will the worker need? Alright, so first thing we need to know is the area of the golf course to know how many total square feet are in that golf course. So it's a rectangle. So using area equals length times width, we're going to give us an area of 2,700 feet times 1,800 feet. Multiply those out. 4,860,000 feet squared. And then we need to figure out how many bags of fertilizer we're going to use. And so one bag is equal to 20,000 square feet. So if I take 4,860,000, do a little conversion table for that. So our conversion of one bag is equal to 20,000 feet squared. So left off the units here. Let's put that on there. So it's 4,860,000 feet squared. So with having feet squared on the top and on the bottom, those units cancel out, which will leave bags as our units left, which we're trying to figure out. And so ultimately it's 4,860,000 divided by 20,000, which is going to give us 243 bags. All right, so next one, you're designing a mat for a picture. The picture is 8 inches wide, 10 inches tall. The mat is to be 2 inches wide. What is the area of the mat? All right, so we're talking about a picture. The mat is like a little cardboard insert that goes around the picture. And so in this example, the mat itself is 2 inches wide, so 2 inches in all directions. inches on all four sides. The picture itself is going to be 8 inches wide by 10 inches tall. And so we want to know the area of just the mat. So in order to figure out the area of the mat, to get just the mat, we're going to have to find the total area of the whole big rectangle, and then we can subtract the size or the area of the cutout for the picture. So it would be area of the total minus area of the picture to get the area of the mat. So the total area, we're doing length times width for the whole picture. And so we have to recognize that for the width, we're adding 2 inches on each side to the 8 inches. That'll be 12 inches wide. And then for the length there, the picture is 10 inches, but then it's 2 inches on each side of it. So it'll be 14 inches. So we're doing 14 inches times 12 inches. So give us 168 inches squared. And then the area of the picture is just the picture measurements, length times width, so 10 inches times 8 inches, 80 inches squared. So area of the mat, it's going to be the total area, 168 inches squared, minus the area of the picture, 80 inches squared, which is going to leave us with 88 inches squared. And that will be the area of the mat. And lastly here, we are making a triangular window. The height of the window is going to be 18 inches, so that top vertex to the base. At a right angle is going to be 18 inches. And we don't know what the base is, but we know that the area is 297 inches squared. So since it's a triangle, we're going to use the formula area equals 1/2 the base times the height, which we also know that the area is equal to 297 inches squared. So plug that into the equation, and we have 297 inches squared for the area. It's going to equal 1/2 of the base, which is what we don't know, times the height, 18 inches. It's going to give us 297 inches squared equals 1/2 times 18 would give us 9 times b inches. And divide both sides by 9 in the inches to get b by itself. So 9 cancels, the inches cancel. 297 divided by 9 is 33, and the bottom inches cancels and one of the top ones, so 33 inches is equal to our B value. So the base of that triangle would be 33 inches. So that completes section 1.7.